140 kilogram rocket, that's the total mass of the fuel in the rocket, burns 110 kilograms of fuel at a rate of 3.2 kilograms per second with an exhaust velocity of 810 meters per second. Okay, so the first thing to do is figure out the initial and final masses. So the initial mass is 140 as it sits on the launch pad with all of its fuel. There it is, right? The final mass is going to be that 140 minus the fuel that it burns. So 140 minus 110 is 30 kilograms. So when the last molecules of fuel are leaving this rocket, well, come on, baby. Okay. It's got a mass of 30 kilograms. Starts off with 140, right? The next thing to do is figure out the thrust of the rocket. Notice I'm telling you the thrust in these problems because everybody messes that up. Okay, but let me show you how to do this. Okay, so force times time equals mass delta V. Okay. Now, our delta V for the fuel is 810. Really what we're doing, by the way, is figuring out the force on the fuel. Okay, 810. And there's lots of ways to do this. If I want to use that 110, though, I've got to figure out how long it takes to burn it at this rate. So I'm going to do this instead. I'm going to say that it's 3.2 kilograms in 1 second. That works, right? So in a way, this is a little bit easier maybe than the other type of problem that we're going to throw at you. Okay. So ultimately, the thrust is just the mass burn rate times the exhaust velocity, right? So 3.2 times 810 is 2592. The thrust of the rocket is 2,592 newtons. Okay, now by the way, real liquid fuel rockets kind of warm up and the thrust gets more, and you know we're not going to go there. All right. Okay. So now what we got to do is figure out the initial and final accelerations. For the initial acceleration, the mass is 140 kilograms, and the thrust, the upward force, is our 2,592 newtons. The force of gravity, the force the Earth is exerting on this, is going to be 140 times 9.8. Is 1372. Okay, so 140. That's how it's a force down, right? And then we can just set up our F equals ma, right? We've got 2,592 up, 1372 down. That equals mass, and the mass is 140 kilograms, right? Times A. All right, 2592 minus 1372. I get 1220, and then I'm going to divide by 140. So divided by 140, I got 8.71. So the initial acceleration is 8.71 meters per second squared. Alrighty. Now for the exciting final acceleration, I'm going to go. We still have that 2,592 newtons upward. The force down, though, is only going to be the final mass, right? This is 30 kilograms. 30 times 9.8. That is 294 newtons, only 294 newtons down. So now we're set. Now we can go 2592 minus 294 is equal to the mass, which is 30 kilograms, right? Times A. Okay, so 2592 minus 294 is 2298, and then divided by 30. 76.6 trombones. Sorry. Ta-da! There it is. Right, so the acceleration definitely increases because the force of gravity gets less and because the inertia gets less. Both things happen.